Before we move on to Chapter 8, Vapor Power System, there's one thing I want to point out. Let's recall if you have a P versus nu diagram, for example this one, we have a curve 1 to 2, which is an expansion process because pressure becomes smaller and volume becomes bigger. The area under 122 is equal to W total per unit mass. And what is W total for a control volume? It has three components. They are WCV, P1V1, and P2V2. WCV comes from the moving parts, such as the moving of the piston or the moving of the blades. P1V1 is the work at the inlet. It's a negative sign because at the inlet, you push the control volume consumes work. And same thing happens at the exit, which is P2V2. P is pressure, V is volume. The reason why it has a plus sign is because at the exit, it is the control volume that pushes the fluid. So the control volume generates work. So we're plugging this new expression of W total back into our previous equation, and then this is what we get. Area under 1 to 2 is equal to WCV per unit mass minus P1 nu 1 plus P2 nu 2. And then we perform algebra. We move WCV per unit mass, which is usually the one we're looking for, such as the movement of the piston or the turning of the blades. It is equal to area under 1 to 2 plus P1 nu 1 minus P2 nu 2. Is it possible for us to visualize WCV per unit mass on this diagram? Yes, so let's do that. So the first term in the right-hand side is area under 1 to 2, which is represented by the red part. Area under 1 to 2 plus P1 nu 1. What is P1 nu 1? P1 is the height of the green part, and nu 1 is the length of the green part. So P1 nu 1 is the area of the green part. So we perform addition for those two terms. And then the third term in the right-hand side is to subtract P2 nu 2. Where is P2 nu 2 on this diagram? P2 is the height of the blue part, and the nu 2 is the length of the blue part. So P2 nu 2 is the area of the blue part. And then it is subtraction. So red plus green, and then subtract blue. What is left? What is left, as you can see, is the area to the left of the curve 1, 2, 2. Is it possible for us to find an equation to calculate the area to the left of 1, 2, 2? We can turn this diagram counterclockwise 90 degrees. So nu becomes the y coordinate, and p becomes the x coordinate. So now let's take a look. We just need to calculate the area under 1, 2, 2 now, instead of to the left of the curve. How do we calculate area under 1, 2, 2? If you calculate the area, that is height multiplied by the length. What is the height? The height this time is nu. And what is the length? The length this time is pressure. However, nu, the height, is not constant. So what do? We change multiplication to integration. So that's why this equation becomes integral nu dp. Nu is specific volume, P is pressure. P1 is initial pressure, and P2 is final pressure. And this gives you WCV per unit mass. We will use this equation quite often in Chapter 8.